Hello there. My name's Harry. So, you want to know what Esso get up to at Folly? Well, our story begins a couple of 100 million years ago and took millions of years to happen. Anyway, several zillion microscopic marine organisms perished, poor wee things, and sank to the seabed, which was tough luck for them, but very good news for all of you. Why? Because over the next few million years, those tiny creatures were buried in sediments, where special bacteria which can live without air worked on them. Increasing pressures and temperatures caused chemical reactions, and they were finally changed into hydrocarbon molecules, like me. As you can see, my friends and I come in all shapes and sizes, but we're all mainly made up of carbon and hydrogen atoms, and together we form what you call crude oil and natural gas, though of course we're not awfully keen on that crude bit. Anyway, this is a story of how we can be changed and turn up in all kinds of different places. Some you'd expect, and some you might not. But that's jumping ahead. We've still got millions of years down here before those oil people find us. Now, why don't you just chat among yourselves while we wait? My, doesn't time fly. Esso found me here in the North Sea, one of the biggest oil and gas provinces ever discovered. And now, our journey really begins. Some of us go by undersea pipeline to the Southern Vaud terminal in Shetland. And for others, it's all aboard a tanker bound for Folly refinery. In fact, these days a fair bit of the crude oil refined by Esso at Folly is shipped in from the North Sea. Why not all of it? The short answer is economics. You see, we North Sea hydrocarbons are of such excellent quality that it simply wouldn't be good business to use us for everything. No. For some of the more basic products, we are blended with less expensive crudes from other parts of the world. Oh, looks like we've arrived already. Good heavens, it's enormous! Apparently, it's the UK's largest oil refinery, covering over 3,000 acres, but you know, it wasn't always like that. No, there's only been a refinery here for about 70 years, a mere blink of an eye to a hydrocarbon molecule, and to start with, it was practically a cottage industry. But demand for oil products grew rapidly, and so did the new refinery that Esso started building in 1949. And since then, they've never stopped changing, updating and generally improving the facilities here. So, back to the present day. And here we are, waiting to be refined. That's us in there. Now, you may find this hard to believe, but even though crude oil is made up of hydrocarbon molecules like me, it's no use as it is. No, it's just a raw material. And before you can do anything useful with it, my molecular friends and I have got to be sorted out, cleaned up, and generally knocked into shape, which is why we're here.
It doesn't sound much fun, Harry.
No, Doogie, I suppose not. Anyway, the first step in refining is the sorting out part, using a process called distillation, which takes place in a tower like this. Now, you know that different liquids boil at different temperatures, don't you? Of course you do. And when a liquid boils, it turns into vapor, like the steam that comes out of a boiling kettle. Well, that's how distillation works. No, I don't mean that you just make a cup of tea and you wait for it to happen. No, just you hang on there. I'll show you. What happens is that the crude oil is piped through a large furnace where it's heated to about 400 degrees Celsius.
How many degrees, Harry?
About 400, Dougie, which is enough to turn you and most of the other crude oil molecules into vapor. But not all of us. Oh, no. The biggest, heaviest molecules, like me, have an even higher boiling point, so we stay liquid, which means that when we pass into the tower, we sink straight to the bottom, where were taken off to be made into heavy fuel oil or bitumen for putting on roads or lubricating oils. Anyway, the rest of the crude oil molecules, those that are still vapour, rise up the tower. Now, this is the clever part. The temperature inside the tower is computer controlled, so that it ranges from around 400 degrees Celsius at the bottom to about 100 degrees at the top, which means the heaviest vapours, those with the biggest molecules and the highest boiling points, turn back into liquids near the bottom. And only the very lightest vapours reach the top. It's like a lift, with passengers getting out at each floor. First, the heavy molecules that make diesel and gas oil, then kerosene, which makes jet fuel, then naphtha, which is mostly used for making into petrol. Only on the very top floor do the smallest molecules remain vapour. Some of this gas is used as fuel for the refinery. A good idea, eh? Saves money. The rest is liquefied and sold as propane or butane, which are used for everything from home heating, industrial kilns, to camping gas stoves and blow lamps. In fact, after distillation and some cleaning up, propane and butane are ready for use, but they're the only finished products at this stage. The rest of us hydrocarbon molecules are still just raw ingredients, and there's an awful long way to go yet before we're ready to be used in products. So, which oil product is in biggest demand? Petrol. No prizes for guessing that. And as you know, petrol's blended from naphtha. But here's the snag. Every tanker load of crude oil that arrives at the refinery is made up of a different mixture of hydrocarbon molecules. So if all you did was distill the crude oil to sort out the molecules, you might not have enough of the kind you wanted. But never fear. Esso engineers have cracked the problem. How? By taking large molecules like me and cracking them to make smaller molecules. First, they take the heavy residue from the bottom of the distillation tower, those of us that remained liquid, and distill us again, but this time under vacuum conditions. In a vacuum, we vaporize at lower temperatures, so now we can be sorted by boiling point, just like the others. Some of the super heavyweights still refuse to boil. They're made into heavy fuel oil or bitumen for putting on roads. The light heavyweights can now be used for manufacturing lubricating oils. But for those of us in the middle, it's off to the CAT plant, otherwise known as a catalytic cracking unit. Cracking works by using heat and a substance called a catalyst to bring about a chemical reaction. Good grief! Well, I suppose it's one way of losing weight. But as you can see, cracking doesn't produce molecules all of the same shape and size. Oh no, we need to be sorted out again. So back we go into another distillation tower. Well, that's an improvement. This time I almost made it to the top. I must have turned into a gas. And look below. There are lots of new naphtha molecules for making more petrol. In fact, cracking enables Esso to produce twice as much petrol from a barrel of crude oil as they'd get by simply distilling it. But increasing the quantity of naphtha for making petrol is only part of the story. It's just as important to improve the quality. I mean, just look at Gordon here.
Bunny breeze, where the sun shines bright.
Oh dear, that is awful, Gordon. And what's more, if you tried to run your car on Gordon in his present state, you'd have real problems. No. High-quality modern car engines need high-quality petrol. So before you can put Gordon and his pals into your fuel tank, Esso have to knock them into shape by processes called isomerization and reforming. This is their isomerization unit, a multi-million-pound plant of which they're justifiably proud. What it does is to rearrange the atoms within a molecule without altering its size. See you, Gordon? They're going to rearrange your atoms.
By yon bonny banks and by yon bonny braes, where the sun
Sounds like a changed
shines
character.
bright on
And in the new
Loch
shape, Gordon and all the other naphtha molecules will burn much more efficiently when they're blended into petrol, as they will have a higher octane rating. But I know what you're wondering. You're wondering what plans Esso have for me. I mean, what was the point of breaking me up into tiny molecules? I'm too small for petrol now. Well, the next thing that they're going to do is to build me up again in this plant behind me. It's not as crazy as it sounds, you know. You see, by joining me to other small molecules, they can make a completely new kind of larger molecule, like this. I've been polymerized. And although it sounds painful, it means that I've now got other uses. In this particular case, I've got a very interesting future. Because now, I'm the right size to be used to help make plastic products. I'm going to be passed on to a plant operated by Esso's sister company, Exxon Chemical, also here at Folly. In fact, several different plants at the refinery enable Esso to create the ingredients for all kinds of different petrochemicals. Designer molecules, if you like, made specially to meet demand. And the beauty of it is, we're mostly made from molecules which could otherwise only be used for heavy fuel oils, which make us much more valuable than we used to be. And, by the way, talking of Exxon Chemical, they'd never forgive me if I forgot to mention their plant at Fife in bonny Scotland. Hey, capable of producing well over 500,000 tons of ethyl in a year, and as safety and environment conscious as Folly. You know, my hydrocarbon friends and I have come an awful long way since we left our home under the seabed. But although we've been brought up, shipped out, sorted through, broken down, knocked into shape and built up, we're still not ready to be used in Esso products. Whatever processes we go through, we all need to be cleaned up. Why? Because many of us contain impurities that could be harmful to the environment. Take Winifred over there. She's going to become fuel for heating somebody's house. Now, she's mostly made up of hydrogen and carbon like any other crude oil molecule. But the big atom is sulfur. And that wouldn't do you much good if it was burnt and ended up in the air you breathe. So, you're going to have to lose your sulfur, Winifred. It's into the desulfurization plant for you. Whee! Lubricating oils, too, are a case for special treatment. Often the feedstocks from vacuum distillation contain unwanted ingredients, waxy or aromatic compounds that could affect the performance of the finished product. So, here at the Folly Lubricants plant, they're given a thorough cleaning. Actually, every one of the products produced from crude oil needs some kind of treatment before it can be blended to reach its final state. Now the refinery's work is nearly done. It's been a long haul. And as I'm sure you've noticed, it's involved an awful lot of little flashing lights and assorted gadgetry, or state-of-the-art technology, as they prefer to call it around here. Every single process is controlled by computer. Temperatures, pressure, flow rates, probably even the coffee machine. No, say what you like. Esso don't mind investing money to give us hydrocarbon molecules the red carpet treatment. I mean, just look at this. This is an awfully clever piece of plant called a resid-finer. Its job is to take the really heavy molecules from the distillation unit, break them down, and clean them up to make even more useful molecules which can be processed further. But you know, speaking from personal experience, I'd say there was something even more valuable here at Folly. That's right, the people. With the petroleum and chemical plants, there's over 2,000 of them. You've never seen such a hard-working lot. They keep the refinery going safely and productively 24 hours a day, 365 days a year. Dedicated? Oh, I should say so. But you know, all the investment in technology and people has been worthwhile, because now they've finally succeeded in preparing all our crude oil molecules and we're ready to be turned into the many different high-quality products that Esso make. But we still have to be blended. At least most of us do. Do you remember the kerosenes which came off the distillation tower about halfway up? They don't need blending. They're ready to be used as jet fuel. But they're the exception. Take Esso lubricating oils, for instance. Would you believe there are over 500 different blends, each ideally suited to a different kind of engine or machinery, and each containing its own special ingredients? Esso motor oils, for example, contain extra chemicals called additives to help keep car engines clean. It's precision work achieving the perfect blend. The same applies to petrol, which is normally blended from 4 or 5 different components. Of course, these days, more and more people are running their cars on unleaded fuel to protect the environment, which is something Esso are all in favour of. To make unleaded petrol, they have to change the blend of naphthas, leaving out the lead compound and using more of the highest quality molecules. An expensive, but very worthwhile process. In fact, Esso were the first company to introduce unleaded petrol in the United Kingdom back in 1986. While on the subject of improving the environment, I must say, from what I can see, Esso really do care about the environment. They're doing their best to make the whole business of oil refining a good deal greener. It isn't easy. A huge oil refinery is never going to look like an English country garden, I'm afraid. But Esso are always on the lookout for the best practical solutions to environmental concerns, and they're prepared to spend money finding them. For example, they've made a major investment in treatment facilities to clean up over 100 million gallons of water used by the refinery each day. The water's regularly sampled and analysed to check for any pollutants, and every year a team of marine biologists makes a study of the plants and wildlife of the salt marsh area where the cooling water is discharged. Esso have also succeeded in dramatically cutting industrial waste and emissions into the atmosphere. And talking of cutting down, they've found all kinds of ways of conserving energy, for example by generating their own electricity using steam from the refinery. Do you know, they've even done their best to make themselves invisible. They've planted thousands and thousands of trees round the refinery. It's part of Esso's policy of being a good neighbour to the local community, which of course also involves providing jobs, using local contractors, and supporting all kinds of activities and events. In fact, Esso's total contribution to the local economy is over £50 million a year. And as you'd expect, a company that cares about the environment and the community also looks after its own people. At the Folly refinery, safety is a #1 priority. So much so that Esso staff are actually less likely to have an accident at work than in their own homes. It's only us hydrocarbon molecules that get knocked around here. So, we've finally made it. We've whistled through the refinery, and we're ready to go out into the big wide world as Esso products. It's a proud moment for a hydrocarbon molecule, I can tell you. But for Esso, the hard work isn't over. No. Before they let us go, they still have to check us over one last time. Rigorous quality control, that's what they call it. In fact, as you can see, Esso have the proof that the highest standards are being achieved. And then there's the complex operations of making sure the right product is in the right place at the right time. Some go by road, some by rail, and some by sea. But the safest way of getting the majority of products to distributors and customers all around the country is by underground pipeline. As fuels, oil products keep all forms of transport moving and provide power to heat and run factories, schools, hospitals, offices and homes. Other products include such things as liquefied petroleum gases, lubricants, bitumen for surfacing roads, antifreeze, brake fluid and handy oil. Of course, to make life even harder for Esso, the market for oil products is always changing. In recent years, the demand for petrol and aviation fuel has continued to increase, while less and less heavy industrial fuel oil has been needed. But tomorrow could be a very different story. That's why, here at Folly, they're always looking ahead, planning for the future, to ensure they'll always be able to meet their customers' demands. Okay, I know you're impatient to find out what happened to the rest of the hydrocarbon molecules, which were made into the ingredients for petrochemicals. Well, they're all used in the making of such materials as plastics, synthetic fabrics and rubbers, detergents, paints, solvents, cosmetics, medicine and fashion goods, and many more everyday items you probably take for granted. Me? You mean me personally? Well, when the chemicals people finished with me, they sent me to a company making plastic products. Then, well, to cut a very long story short, I suppose you could say I've returned to my home ground. Ooh, it's freezing. But it's right what they say, you know. There's really no place like home. Anyway, you remember I said I would have an interesting future? Well, I can look forward to another life. I shall eventually be recycled, and I might come back as part of a car mat, or as a Wellington boot. So there should be some travel involved, eh? Look out for me then. Bye for now. Bye-bye.